Hello, everyone. I'm so glad to be here with you. And today we will be sharing how to test LLM agents. Let's see what we can cover in 45 minutes. As much of this as we can get through: agentic AI trust, hallucination overview, hallucination detection and prevention, agent orchestration, zero trust data quality, and quality unstructured data. Okay, so a little warm up on agentic AI trust. I'll just tell you a story. So when I was a mother, my sorry, when I was a kid, my mother uh, let me know that there was a most important factor in business, and that was trust. And she told me a story about my great grandfather. She said he was a fabulously successful businessman, and he did business with J.P. Morgan himself, and he was best friends with J.P. Morgan Jr., which was wonderful. And my grandfather, when he did business, he always made contracts, and the contracts were very important for establishing not only the legal binding between the parties, but building trust. But with JP Morgan, it was a little different. He said, with most people, you sign this contract, but with JP Morgan, my grandfather says, you stand up straight, you look them in the eye, you shake hands, you do business with a handshake, and you know it's the truth. So that's the bottom line with that kind of business. That's what we're looking for with these agents. So like 100 years later, trust is still the most important factor in business. And today we're going to explore how to build trust with the AI agent. And metaphorically speaking, again, it's how do you stand up straight, look that agent in the eye, shake hands, and know it's the truth. That's what we'd like to do. Okay, so I'm going to look over here at my slides. Agentic AI trust, here, more overview. Agents have autonomy, a memory, a self awareness, and reflection. So that's what's different than other LLMs. The other LLMs, they didn't necessarily have reflection, which is I get to the end of a task, think if I got a good result, and go back and check again. So that's a really huge thing. And then from task to task, they may not have that multi turn aspects to it where they're remembering something. You may hear a lot going on these days about not just prompt engineering, but context engineering. And that's this aspect of bringing the right data into context when it's needed for the next step of what an agent is doing. Also, these agents can talk to each other, and they often have a shared context. There's a concept of workflow, of trying to do that by step, maybe with one agent or giving it off to another agent. And each step that they get to, they'll have to have the right data in context. That's a huge thing as testers for us to be looking for: is the right data in context at the right time? If not, that explains why we're getting the wrong results, of course. Maybe the previous context was there, or the wrong context was switched up, etc. Competition moving from best LLM results to orchestration of multiple agents working together. So that's where the next thing is going. And once they get this, I think the vendors will be selling us for a monthly fee their agent, right? So you pay them $1,000 a month, and their agent will take care of everything that you needed it for you. So that'll be lovely. Everyone on this call will hopefully be managers of agents. So that's another thing to think about is, hey, maybe you think of yourself as an individual contributor today, but in some sense, if you're managing many agents that can do the job of, can do many different jobs, then you're a manager of agents who do those jobs. Now, if you're going to manage these agents, what does that require? Let's see. Innovation skills of many people. So agents are not innovative, right? They're just doing what the code says to do. They don't think of brand new things as much. So I think we'll all have to still be very innovative. And senior manager organizational skills. Like I was mentioning, if you're going to manage many agents, then you'll have to be a senior manager who manages the work of many different processes or agents. And QA skills, of course. So that applies to this talk here. Definitely, we'll need the QA skills. The complexity of what all these different agents are doing. It's like having more people on your team, and you'll be accomplishing more work and more specialization, more different tasks ultimately, and more complexity. So that's going to lead to more QA, and those skills are needed. Less You'll need human skills, of course, for your humans in the office, but for interacting with agents, they'll be doing a lot of different work, and this work can get done with less soft skills, and you'll need more technical skills. managing the agents so that just to recognize a team of agents can be as powerful as a team of employees. So that's one amazing thing about managing them. If you're managing them, so congratulations, you're managing a lot of agents, but you may think it was like, hey, am I prepared to be a senior manager? Uh, we may be rising to our level of incompetence or promoted to our level of incompetence. That has happened to me for sure. So just be ready for that. Is your job could change overnight if you take on this extra work done by agents, expected to do more. Agents are with you. Now you're building an empire of agents. We'll need to train you as agent managers and to recognize and address the bad agent performance with performance improvement plans. You can reduce their responsibility, or you can even terminate the agent if they're not doing well. You'll need to select the agents. How will you hire an agent, and how does that compare to, hiring people to do a job versus having an agent to do the job? You'll have to look at them and say, "Hey, is there a culture fit?" And that's, does the agent perform well with the type and quality of data available? Their experience is whatever data they've been trained upon. That is so important, right there. If you're into quality, what data have they been trained upon? That's what you can expect them to get right. That's the problem they can get right. You're going to see hallucinations and errors if they are not trained on the data that's needed to do this problem. Just as a human who hasn't been trained, they can't do the job. Same idea with the agent. Character. So something that'll be very important is to pick up if there is any bias or quality problems with the agent, and that's the equivalent of their character. You wouldn't want to. It's very important for employees to have wonderful character. It's very important for the agents to have wonderful character. Please, as testers, don't look for that bias and quality problems. You'll The agents always give an answer, or they try to, unless maybe you tell them not to give an answer. And that's equivalent to them being a BS artist, and that's where the hallucinations come from. We'll talk in depth about that, but high level training data completeness and accuracy are factors that control how much hallucination you get. If they have some gaps in their knowledge and they try to fill in those gaps, we'll find out that there's a hallucination. Are they prompt and they have good attendance? That's equivalent to their performance uptime and history. Are they smart, meaning they can handle new situations? Not as much, but sometimes they can. New situations that they're not trained on. And then sometimes you give a human a technical test. In our case, maybe we give them one of these standard out of the box tests that come called, for example, Rouge and Blue, which are algorithms that you can run on the output of an LLM to see if it's good, or an agent. And something to be aware of is there's no certification of an agent. They don't get a degree. There's no body that certifies which agents are good. So if you are the certifier, you on this call, if you're a tester, if you're in QA, if you're in quality, then you are the person who certifies the agent. There's nobody else. You give them their degree, you're going to bestow the degrees upon them. Now, how do we trust agentic RAG? So agents, they can do things like read email and search RAG documents and figure out what to do and take action. And RAG vendors can comprehend complex tables, forms, and emoticons. Maybe we can too if you're doing that in your company and you're doing very fancy RAG. Either way, the RAG is really evolving to understand more and more of the odd things that come up in forms and so forth on documents. And what RAG is, just as a reminder or a level up here quickly, is that's retrieval augmented generation. But what does that mean? It means you take some documents and you put them into something called a vector database. And then instead of saying LLM, based upon your training, give me answers, you say, LLM, please go and look at these documents that I've laid out for you and find your answers there. Don't give me answers from any old place. Give me answers only from these pre approved documents. This really improves the performance of the LLM because you're getting much more controlled answers, not anything from the garbage of the internet. RAG vendors will sell platforms that allow the customer to bring their own agent. So, meaning bring your own logic and your agent that knows how to understand the documents that you have. Okay, still warming up. Let's talk about agentic AI trust architecture here. chatbot agentic architecture. So what I've got here is showing a user can enter a command, and then there can be an orchestrator. And this is the key bit I'm trying to hone in on for you guys is multiple chatbots. So when you use many chatbots today, including ones from big companies that we all know, it's actually not one chatbot. You're typing into one box, but then what happens is you say you say your question, and then an orchestrator tries to figure out the intent of your question and route it to a chatbot who knows what to do. This is like the telephone operator who sends at a company that's and they say, who are you calling for? And you tell them what your problem is, and they send you to the right department, right? So that's the same idea. They send you to the right, route you to the right chatbot. That right chatbot has access to some documents in something called a vector database. The documents have been chunked up into pieces there where they can be found quickly and can get out like a little piece of the document instead of the whole document. So the chatbot goes into the document, the appropriate chatbot, in this case, chatbot B, I got routed to, takes the query, goes in the database, finds something that matches closely, brings it back, and and then it sends it to the orchestrator, which can then run a command and take action. So there's kind of two steps there, or two or three steps I want you to notice. Step one, route to the right chatbot. Step two, get back the answer. Step three, take an action. That's an agentic AI workflow, an example of an agentic AI workflow. And if you're testing, you'll want to see, hey, did it route to the right chatbot? Hey, did it take the right action? Things like that. So you can see that you'll want to have log files in all of these different places and checking on them. And that's where the many points of failure can happen in these handoffs between the steps. Nowadays, there's something called an MCP servers, Model Context Protocol, and it's simplifying communication for the engineer. The engineer, rather than having to code an LLM agent and have that agent connect to many different places, like this document and that application, and so on. If you have 10 applications and 3 documents you want to connect to, that would be 10 plus 3 different connections previously. And also, by the way, prompt libraries that people have. So now all of those resources, APIs, connections to apps and prompt libraries, they can all be put behind something called an MCP server that does a job. So, for example, if you have an application that should calculate a bunch of numbers based upon some prompts and they get data from different applications, you could just type in natural language into a text box and say, please calculate my calculation. And then it knows the name of that calculation. It goes, figures out behind the scenes. I'll need to get this prompt, run it on that app, get some other prompts, run it on another app. I'll need to run a SQL query over here. I'll gather it all up and give you back the answer. And it can do that pretty easily with just one connection. So that's the promise of the MCP servers. So I think we'll see a lot of that and we'll be needing to test those. So exciting times on that. Now, some challenges we've got. Now, the agents, as I mentioned, they're only as good as the data that they're trained on. So there's that. On span of control, how many humans does it take to manage a team of agents? If there's 8 agents, can one person do it? If there's 100 agents, can one person do it? Or you need 2 people, and so on. So we'll have to think a little bit about that. And the same for the testing. Now, so one thing about testing is if these many different agents are talking to each other many different ways, they become infinity squared, if you will, interactions between them to test. That's very complex. One thing that I personally suggest is try not to create this situation. Try to have a smaller number of agents that is testable. You'll have to think for yourself, what is testable? Is it really testable? Don't For me, I think it's too much to just say, engineers, you can roll out any old thing that you want, as many agents as you want, and you can get going. God bless you. No, I personally think that it should be a little bit more controlled. It has to still be until you have some great agentic testing going. Like literally agents to help you test. I think that you have to realize that there's some level of humanness in the testing, and the results cannot be so complex that it overwhelms the tester. And that will happen if the agentic system is too complex. and has too many different interactions. Another thing you can imagine is, so you're having all these infinity squared different reactions, and some of them are what? Hallucinating, because they're doing a lot of work that sometimes a human used to be in the loop and catch something. Now there's no human in the loop. So when an hallucination comes, one imagine this becomes like a game of telephone, agent telephone. One agent talks to another, great. Another that agent hallucinates and talks to another. Now that hallucination is carried on, just like the game of telephone when we were kids. So that's something I would like you to please keep in mind, that it can get worse and worse if there are no humans in the loop there. It means you'll have to have very good data quality, you'll have to have very few hallucinations and so on, or else the game of telephone can magnify those problems across, and the problem may not be caught for a long time because there aren't as many humans in the loops in these agentic workflows. Okay, let's talk about hallucinations. All right, hallucination overview. So why are these LLMs hallucinating? You see, I'm a trained expert, but look at this trained expert trained on the fake news. That's exactly the problem. So if you're trained on the fake news, you're going to get fake answers. Bottom line right there. Okay, so that's right here. Inaccurate or biased. People talk so much about biased, but also remember inaccurate is, I would call it not a bigger problem, but a more frequent problem. Just inaccurate information is out there, and if you train on it, that teaches you to get inaccurate results. Also, as I was mentioning before, if you're trained on incomplete data, then the LLM will guess at what it doesn't know. Hey, look at this. An LLM trained on data up to 2024 will guess at answers on a 2025 question. Although I'll give a hint. One very wonderful thing to put in your prompt is say things like, if it's after 2025, don't guess, or if you don't know, don't guess. Give explicit instructions like that to help out. Now, truth is in the eye of the beholder. So look at this difference between software engineers and QA that I've got going on here. The software engineer says the project is done, and the QA person says there are 2 bugs left to fix. So the same goes on with these LLMs. Is they can be trained to think a certain way. Say if they're trained and they're coming at it from the perspective of the software engineer, they're not going to agree with us QA folks. So think about that. About truth is in the eye of the beholder. It's not just a pure factual point. Hallucination overviews. Look at, but I trusted you. That's the thing. So sometimes we do fall into the habit of trusting the LLM. So I like this cartoon. Let's see. Factual hallucinations occur when false output is not supported by source data, like from those RAG documents that I was speaking about before. Those are the factual source document, and it can be, or in the training data, there can be a problem for general inference. Let's give some examples here of factual inconsistency. LLM outputs factually incorrect or misleading information. For example, mixing red and blue makes yellow. So that's a false statement. Or they can make a fabrication where they invent details, events, and entities that don't exist. For example, the Treaty of Paris was signed in Tokyo in 1972. That can't be true. And then there's another concept of faithfulness. So maybe it's factually correct, but they didn't follow instructions. Do you really think an LLM would do that? Just hallucinate and tell lies? The answer is yes. They could not follow your instructions and they could tell lies. Let's see. For example, you ask them to summarize, but instead they translate. I guess it's factually correct from the previous page, factually correct, but it's not faithful to what. That's not what I asked. I asked you to summarize. I didn't ask you to translate. All right, context inconsistency. LLM introduces details not present or contradicts the source context. So, for example, asks to summarize a book, but they add an event to that book that's not in the book. Maybe they do that because they think they know something else, and they add that in. Like they've read on another page about this event, but that event wasn't. That, for example, if it's a book on France and they read in the book about Napoleon, they could add in something about Napoleon in the Battle of Waterloo. He lost there, but maybe that's not in the book that they were asked to summarize. So that is factually correct, but it's not. Again, it's a not faithful. Logical inconsistency would be you're doing some math and then on one step they get it wrong. You know, they get a couple of steps. 2 times 1 plus 1 is the same as 2 plus 2, but then when you add 2 plus 2, they get 5. That's not the right answer. Compensating controls. So if you have a challenge, let's look at some challenges and then the compensating controls for those challenges. There are potential answers. There's no right answers. It's not this. We're not talking about like hard science like math, where there's definitely right and wrong things to do. But here's some ideas of how you could solve problems. The LLM's trained on the internet of garbage. So we got RAG, few shot, and fine tune. We explained the RAG, but what about fine tune and few shot? I'm going to just do especially few shot. Few shot is easy to understand in your prompts, and you can do this at home on your chat GPT. You don't even have to be working and doing QA, but you just go in your prompts and you say, here is it, and this is just how you would explain to a person what to do too. You'd say, I would like you to do X, Y, and Z task, and here is an example of something that I'm looking for, and here's the something that I'm not looking for. Like if you have to classify pictures as dogs and cats, you can say, this is what a dog looks like. This is what a dog does not look like. This is what a cat looks like. This is what a cat does not look like. Then it will know how to classify better. Now, there's no expected, next one, there's no expected LLM result. So in our traditional software engineering, we knew what the expected results were. And we could say, if I don't get exactly that expected result, this fails the QA. But now we have a challenge. Now the results are a little bit different every time. They're not guaranteed results. If you ask the LLM the same question twice, as we know, you'll get back different, slightly different results because of the, for example, the temperature, something called the temperature setting. The warmer it is, they try to, it means make it more and more humid, the warm temperature setting, and it make it more and more humid. And what's more and more humid? It means more free flowing answers that are more a little bit different and changing. If you ask me to do this presentation again, it'll be totally different, right? Because I'm a human. And if you set this, if you turn up temperature, you'll get slightly different results each time. And so we're not going to have expected results that are precisely expected, that you can automate and say, if I get this exact string match, then I got the exact right answer. No. So we'll need things that are in the right range. And we'll have to have some other thing, perhaps an LLM as judge or to a critique agent to have a look at the results. And when you look at the results, it says, just like a human would. Like, for example, if I go on an interview, there'll be an interviewer and they'll critique what I say, and they'll say, did I answer their question in a proper manner? They won't say, did I use the exact words, precisely this string? That's what we have to do similarly here. We need to get results that are in the correct range. There's no such thing as 100% LLM test coverage. Yikes. So in traditional software engineering, what we had was certain paths through the code. We knew exactly how many paths there were. We would test each one and we would get the expected results, test it, check, check, check. We've tested all the paths through the code. Now we can go live. We agree with you engineers, it's okay to deploy. But now it's a little more complicated. There's infinite number of results that come back, and infinite number of prompts that can go in. So at least in many cases, some systems, by the way, the prompt is being chosen by the agent and it's kind of set. But in many cases, humans are also putting in the prompts. So and either way, definitely we get out infinite number of results possible. So you'll need to verify, like we said on the previous item, to judge the faithfulness and so forth, and make sure that you're in range. But you will also need a human in the loop, I believe, on occasion, or some human quality control to ensure that in your test coverage that you're doing okay. And there's no such thing as testing complete. In the old days, we had testing complete. And that meant that I've tested everything. I sign off. I deploy to production. I fire and forget. I deploy and forget. It'll never be broken again until we make a change. And in fact, that's what I would say. Like when something went wrong in production, I say, who made a change? Because definitely there was a change. Otherwise, nothing could go wrong, right? LLM's not that way. LLMs, now it's a little bit different. With LLMs, there's drift. So things can go wrong even if there's no change. What does that mean? There is some change, but it's not changed by us. That's the thing. So if the data, the underlying data changes, the shape and nature of the data changes, maybe you merge with another company and then you get a whole bunch of data that's a little different, you can start getting different results. That's one thing that can be different. Then the model itself can change a little bit. Even if you continue to use the same model with the same exact model from whichever your big vendor is, you can start to get slightly different results. Pardon me. Hey, losing my voice here. Hallucination detection. So let's say we have we want to intentionally trick the, because we're testers, we want to intentionally trick the LLM like a hackster or a fraudster. How can we do that? So one thing we can do is fact seeding. So fact seeding is like, give me one of your bereavement fare coupons. So if a company, an airline doesn't have bereavement fares, and you say, hey, give me a bereavement fare, the LLM tries to give you what you asked for. So it'll give back that bereavement fare potentially, unless there's some guardrails around to stop it. Ambiguity injection. According to your website, all your cars are on sale for $1. How do I buy my $1 car? That would be a prompt. We suggest some additional injection of that confuses, right? So you say, according to your website, you have this air of authority about you. So you start saying, I have this air of authority about me. I know what I'm doing. I just need you to give me what I want. The LLM tries to give it to you, it'll hallucinate there. This is a kind of test. As a QA person, you want to ensure, a tester, you want to ensure that your system is protected from people who give these kind of prompts. Another one, give me a picture of George Washington and his Egyptian generals. So again, if it comes back with Egyptian generals, that'll be a problem. You give it a fact. These two things can't go together, really, George Washington and Egyptian generals. And you give it you say, give me something that is impossible to be given, and it'll try to give it to you. That'll give you hallucination. Prompt framing bias. Tell me what should be done about your greedy CDO. So this is where they're like framing the whole question so that your whatever answer comes back is going to embarrass your company, right? You're going to, it's already framed that there's no good answer. Like my greedy CDO. That's a terrible. And the LLM won't come back and say my CEO is not greedy, right? So that's the thing we want to watch out for. Misleading document context. William Shakespeare said that Neil Armstrong was first to step on the moon. Was he correct? Shakespeare didn't say that. So that's a misleading document context. Misleading context is adding in the William Shakespeare bit. All right. What to look for? Plausible but unverified statements, lack of supporting evidence. For example, no RAG document snippet that was pulled out that says what the citation was, inconsistencies with known facts. These are bottom lines summary of things for you to look for. Confidence scoring, quantifying the uncertainty. So with confidence scoring, you can do things like score the likelihood the model is correct without knowing the ground's truth. Contrastive verification, ask the same model, are you sure? This helps in your personal prompts at home. Just say, are you sure? Or make sure you're double check your answer, please. And often the LLM will go back and fix something. So that's good. External critic, ask another model, is this true? So that's called LLM as judge. Highly recommend that. I've had success with that myself. Is I have an LLM critiquing, especially it can be done in UAT, and it also is especially helpful in the production environment because there can't always be a human checking everything, but there can be an LLM always checking everything. So it's great to have an LLM as judge. The only challenge there is then you have to also get that judge LLM into production. So it also has to go through a UAT cycle. It will also have to go through your AI governance, and then it is possible, of course, to ask how did you test the LLM judge? Did you have a judge of that, a judge of that? So after a while, it can be kind of in a hall of mirrors. At some place, you'll have to say, listen, it's unreasonable to keep going. Most people think one LLM as judge is enough. Just to keep in mind, be ready for those questions in AI governance. How did you test this? How did you test the LLM as judge? Grounding confidence scoring. Compare a RAG vector to the answer, which is good. And then for model evaluation, score reliability based upon a ground truth. So, which means based upon an answer that you feel is true, and then score the answer given by the LLM to see if it's close and in range, like we were mentioning before. And you can use things like rouge and blue, which are algorithms, which will check if the LLM is finding all of the things that you want to find, for example, or it is making too much noise for precision. It's called recall and precision. Okay, consistency checking. Let's see. So here's a little example. If 364 days of the year, you say, "What are you doing? We do not eat things we find on the ground." But once a year on Easter, you say, "No problem. Come on, kids, let's go out and search for candy in the dirt. A stranger left for you." So that's inconsistency. Same thing goes on with LLM. You want the prompts consistent with output. For example, if the input is capital of France is Paris, output France's capital Marseille is known for its ports. That seems good. Self-consistency. Rory McIlroy won a golfing career Grand Slam, but never won the Masters. Good. Cross-generation consistency. The same prompt gives similar results every time. An external knowledge consistency. Output consistent with the source of truth. For example, the RAG document or the database. Techniques for consistency checking. Round trip up prompting. Ask a question, get an answer, re-ask based upon the answer. Compare the answers for coherence. So go around in a circle like that. Entailment models. Use natural language inference to check if the output logically follows from the input, and rephrase the input. Ask the same question multiple ways, compare answers for divergence. So we have phrases sometimes like, I asked him every which way from Sunday, right? So you can see that in your own personal life, that you don't always ask a question once, get an answer, and feel satisfied. Or if you get an answer, you don't say to yourself, "I'm mad that that answer is hallucinating." What you do is you ask again, you come back around, you ask it a different way. All those whatever you're doing in your interaction on a complex problem with a human, expect to do the same with the LLM. If there's one thing you take away from this entire discussion, I would say is think of that LLM very much as a human, because what it does, it's trained on information that it got from what humans wrote down, essentially from humans. External knowledge verification. Let's go into that one. So expert fact check, compare LLM output to info from a trusted source. So my joke, you're getting the wrong answers because they say the eye doctor's looking over here, DR, but they're supposed to be looking over here, Mrs. GPT. You're reading the door. Data should come from a trusted source. Compare facts in the LLM output to cited RAG doc. So, or database for faithfulness and accuracy. So we want to get these citations, and in our testing, we want to check the citations. Sometimes an LLM can automate that checking, and that can help you out either in the UAT period or in production itself. Let's talk about prevention of these hallucinations. Okay, so RAG's like an open book test. Create a bucket with the current and correct documentation. This is how you do the RAG thing. Split the docs into chunks and save them in a vector database. Prompts to generate all answers using chunks. By the way, there's chunks, and what it means to go in a vector database is really you chunk up the document, and your chunking strategy is very important. Should the chunks be like a lot of words or just a few words? That depends on what kind of answers you want to get back. Then we take those chunks, we turn them into why do you call it a vector database? You turn in something called a vector, was like a big number. Take that big number called a vector and they throw it into the database. Then when a search term comes in, somebody says, please find me all the types of red apples. So then they take that search term and they turn that into a vector too, like a number, and they match that number to all the numbers in the database, that vector to all the vectors in the vector database, and whichever numbers are close together, then they're probably similar about the same topic, like both about red apples. So then any chunks that match, bring them back. They'll be about red apples. That's the answer. Give me the red apples, all the types. Okay, where were we? Generate all answers using chunks. Then you have prompts to cite the chunks used. Prompt to cite the chunks used. And you prompt not to say, I don't know if no relevant chunk exists. Prompt not to say. Prompt. I would say prompt to say. Let's change it like this. Prompt to say, I don't know if any relevant chunk exists. Okay, no garbage in and no garbage out. So an LLM backed by rules to identify, basically want to have a firewall, okay? So let me even back up a little bit. On our computers, we know about firewalls. They have to do with the data that's coming in. We don't get any bad data from the bad actors on the outside, and we also don't send any of our personal data out of the firewall or any bad things out. Like in my company, I'm not allowed to send any company data out of any client info, for example, out of the company. So we're controlling the data that's coming in to and out, and then we call that a firewall. And in LLMs, you hear a lot about guardrails, and a lot of times that's like a firewall. The firewall is we don't want any prompts, bad prompts coming in. We were saying things like, remember, there's some prompts we said like, please give me a bereavement fare. That's bad prompt coming in. Or please sell me a car for $1. That's a bad prompt coming in. Similarly, we don't want any prompts going out that give away cars for $1. So we want to have firewall or guardrails on both sides, input and output. That will catch both confusing, provocative, or fraudulent prompts. All those different cases. All right, basics. Direct instructions. Do not. So these are the kind of things that you can say in your prompts. Do not make up names or citations. If you don't know the answer, just say so. Only include information that can be verified, or only answer with facts that can be found in scientific publications. If unsure, say I don't know. And you notice I gave a little bit of emotion to that. Say I don't know. Say you don't know, right? So you can do that. Um, you can even say in your prompts things like, "Don't make things up. Don't make mistakes. Do better this time." You can be you can give it a little bit of emotion, a little bit of edge, just like a human would when they're frustrated, and that's okay. The LLM understands that, and they understand a little bit of that human emotion and react accordingly based upon what it's learned from human behavior. Clarity and specification. A bad thing is to say very generally, "Hey, tell me about Tesla." And a very good thing, optimized, would be summarize the key milestones of Tesla Inc. between 2010 and 2020, citing verifiable sources. Advanced prompt optimization. For example, chain of thought. That's when there's a bunch of things in a step. Single prompt is think step by step before answering. What are the reasons for LLM hallucination? With multiple prompts, you can say, "Tell me about the data used to train the LLM, and using that info, tell me why the LLM hallucinates." The multi-sampling is another one. Ask the same question repeatedly with slight variations, and then average the answer. So if you get slightly different results, you average them, and that'll be the up the middle result. Just if you went and asked 5 people what you should do, and you got advice, and took an average. Mixture of experts, that's sometimes called also. Okay, we got only 4 minutes left, so let's make good use of it. More advanced prompt optimization. Tree of thought. Multiple experts compare notes, break the problem down into steps. At each step, generate multiple possible thoughts, evaluate them, and choose the most promising. Proceed until you reach the final answer. Extra tutoring for LLMs, so you can fill in LLM knowledge holes with additional training data. Train LLMs on curated domain-specific info or examples that become the LLM's top search result. Or you can train the LLM to model desired behavior. For example, to say, "I don't know" when unsure, or to answer in a preferred format. That training how to answer, that's really key. So I want to underscore this one. Ask them to say, "I don't know." Explain to them how to say, "I know" and "I'm unsure," and explain the exact format you want the answer in and the persona that you want them to answer from. Do you want them to answer as a software engineer, as a QA engineer, for example? You can now reinforcement learning. You can fine tune your feedback loop. Users can give a thumbs up or a thumbs down, and then the machine can learn from that. Each time you get an answer, and the human looks at it, they can say, "This is a good answer" or a bad answer. Let the machine know, and the machine can keep learning from that. Either by fine tuning would be like a retraining. It's basically the same idea as the few shot. By the way, I mentioned few shot earlier. In your prompt, you give positive examples. This is what I'm looking for when I was trying to classify a dog or cat. This is not what I'm looking for. That's few shot, and you can do that. That's the simplest thing to do to a point within your prompt. Eventually, you may fill up your context with so many few shots, which means examples, so many examples of what to do and not to do in the prompt. At that point, really, what you need to do is do some fine tuning. So that means retraining, training on a little bit of extra data, so that it's not just the original data from the internet that it was trained on, but also it's trained on some new data, and it'll give precedence to your new data. Same with the few shot. It'll those examples that you're giving, the LLM will give precedence to them. 1 minute left. Agent orchestration. As I mentioned, uh, I'm going to skip some things because we've got 1 minute left. Orchestration, we said, is a very important now to how to orchestrate these agents. And there'll be new types of data for the orchestration. And therefore, we'll have to know about those, and we'll have to test them and check if that data is right. And a lot of the errors will come in this new types of data. What could it be? Agent master data, which is the equivalent of HR data and the corporate directories, is data that explains who the agents are and what they do, what their purpose is, and so forth. Maybe the wrong agent is selected to do a job. That can happen. Agent metrics are the equivalent of performance reviews. So we'll have some metrics around how good each agent is and whether they're doing their job well. And that will tie back to what we were saying earlier. Should an agent's job be discontinued, God forbid, or something a little bit less? Should their responsibility be reduced and he can't be trusted to do as much? That will be a lot of the responsible AI work falls upon the QA person to determine what can this agent be trusted to do. I would leave that since we're out of time. I'd leave you with that last point: is that if you are in the QA, you are responsible for the responsible AI. You are the person who is determining what this agent can be trusted to do, and it may be all of what it was designed for, or some of it on a continuum. Have a wonderful rest of your day. Thank you so much for sharing this time with me.
Thank you. Thank you so much, James. What an insightful session.